Measurement of the speed of light. Light travels at such a high speed, 3 digit. C is equals to 3 times 10 to the power of 8 miles per second. That early attempts to measure its speed were unsuccessfully. Galileo attempts to measure the speed of light by positioning two observers in tower, separated by approximately 10 km. Each observer carried a shattered lantern. One observer would open his lantern first, and the other would open his lantern at the moment he saw the light from the first lantern. Galileo reasoned that by knowing the transit time of the light beams from one lantern to another, and the distance between the two lanterns, he could obtain the speed. His results were conclusive. Today, we realize as Galileo concluded that it is impossible to measure the speed of light in this manner because the transit time of the light is so much less than the reaction time of the observers. Reaumur's method. In 1675, Danish astronomer Ole Reaumur, 1644 to 1710, made his first successful estimate of the speed of light. Reaumur's technique involved astronomical observation of I sub O, one of the moons of Jupiter. I sub O has a period of revolution around Jupiter of approximately 42.5 hours. The period of revolution of Jupiter around the Sun is about 12 years. Therefore, as the Earth moves through 90 degrees around the Sun, Jupiter revolves through only 112 times 90 degrees is equals to 7.5 degree, shown in figure 35.1. An observer using the orbital motion of I sub O as clock would expect the orbit to have a constant period. After collecting data for more than a year, however, Reaumur observed a systematic variation in I sub O's period. He found that the periods were longer than average when the Earth is receding from Jupiter and shorter than average when the Earth was approaching Jupiter. Reaumur attributed this variation in period to the distance between the Earth and Jupiter changing from one observation to the next. Using Reaumur's data, Huygens estimated the lower limit of the speed of light to be approximately 2.3 times 10 to the power of 8 miles per second. This experiment is important historically because it demonstrates that light does have a finite speed and give estimate of this period. Fuse's method, the first successful method for measuring the speed of light by means of purely terrestrial technique, was developed in 1849 by French physicist Armand H. L. Fugit. 1819 to 1896, shown in figure 35.2, represent a simplified diagram of Fuse's apparatus. The basic procedure is to measure the total time interval during which light travels from some point to a distant mirror and back. If d is the distance between the light source, considered to be the location of the wheel, and the mirror, and if the time interval of one round trip is delta t, the speed of light is c equals to 2 distance all over delta time. To measure the transit time, Fugit used rotating toothed wheel, which converts a continuous beam of light into a series of light poles. The rotation of such a wheel controls what an observer at the light source sees. For example, if the poles travel toward the mirror and passing the opening at a point A, and figure 35.2 should return to the wheel at an instant tooth B had rotated into position to cover the return path. The poles would not reach the observer at a greater rate of rotation. The opening at point C could move into position to allow the reflected poles to reach the observer. Knowing the distance d, the number of teeth in the wheel, and the angular speed of the wheel, Fugit arrived at a value of 3.1 times 10 to the power of 8 miles per second. Similar measurement measurements made by subsequent investigation yield more precise values for C, which lead to the currently accepted value of 2.9979248 times 10 to the power of 8 miles per second.